Alright, hi everyone, welcome back to another video of Salesforce Makes Sense. We are continuing our journey of understanding Apex through our Salesforce Developer Masterclass, and I'm glad to tell you that we have completed the 29 Apex use case that we started off with, and these are pretty much 29 different scenarios that we looked at. We learned a great chunk of deal, and for those of you who could not understand the gravity of it, I'll just take you through things that we learned, right? I wanted to show you all that we have learned as part of the last 29 videos or so that where we have covered 29 use cases. So we started off with Apex use case 1, this right here, and we understood how to use list variables, how to take method input parameters. We understood the isBlank function, we understood the not symbol, and we put our best practices into use for the if condition check, and we used the insert command to do a database update, right? That was use case 1. Use case 2 is where we used our decimal variable fields and we put up a if condition to check for null pointer exceptions, and we simply created a formula for calculating the simple interest, and we started using return types wherein we were able to understand, okay, if there's an if condition, you have to return from here, or else this execution, the code execution will run till this particular line of code, right? So we understood how the return statement works. Apex use case 3 is where we triggered an email to a customer by setting up a subject, by setting up a body, and setting up a to address list. So this to address list was nothing but the email address of the customer, and we understood that there's a class called messaging which also has an inner class called single email message, and there's a method that's called send email from the platform from this messaging class that allows us to trigger emails from Apex. All right, that is what we learned from our third use case. Let's look at Apex use case 4. Apex use case 4 was about return contact email. So this was more about a SOQL query. So we understood how to write a SOQL query, how to bind it with a variable by using the colon operator, and we understood that we can use the dot operator to access parent related fields, right? And then we also understood how to put a null check, how to iterate over contact records or a list or a collection, and finally add all of that information to a list and return that as the return type. All right, that was use case 4. We look at 5. This was a very simple use case where we wanted to check if a same contact exists which has the same name and has the same parent name. So we did a check where the name is equal to the contact name, again using the binding operator, and then on the account.name, right? If we found a record and we said that the size was greater than 0, we said that okay, we can return true, and we understood that we'll have to write a return statement outside, and true and false are basically Boolean data types. So our Boolean data types return type was created. All right, what was use case 6? Let's go to 6. So we created and understood that system class is available, and within the system class I can use the today method to actually call and understand what is today's date, which is the current date. And then we basically understood that there's a method called days between that lets us calculate the difference between two dates based on the number of days, right? So we tried that out and we found the approximate age in years because we divided it by 365, and then finally we were able to figure out if the person was eligible for voting or not. Okay, use case 7. Use case 7 was very simple. We all go out, we all share food, and this was more about splitting the bills, right? So we just we took two input parameters of two different data types, and we decided a value that should be the split per person, which was initialized to 0, and then we created a if condition to avoid null pointers, and we simply used the division command, which is a mathematical operator, nothing to do with the use case per se, but we were able to write a small piece of code that can split the bill based on the number of people. All right, what was use case 8? Use case 8 is here. So use case 8 was a method wherein we were checking whether a particular number is divisible by two numbers, 7 and 11, right? So what we did is we understood that there's a mod function available in the math class. So just like system class, you have the math class available, right? So math.mod number to check, 7 tells you whether it is completely divisible by 7 or not. If it is going to return 0, right? Similarly, we did that for the number 11, and if both of them were true, using this AND operator, we said that return true, which means it is divisible by both 7 and 11. All right, use case number 9. In use case number 9, we tried to understand whether you are a millennial, Gen Z, or a Gen Alpha. This was based on the year of birth. So year of birth was our input param in the method, and we just declared a string type, and based on the year when you were born, we just returned a gen type variable. Instead of writing 3 return statements, we simply initialize the value and we put 1 return statement at the end, because this code will only run and only will go inside one of the if conditions, this one, or this one, because the conditions are mutually exclusive. Okay, none of them fall between each other. What was use case 10? Use case 10 is here. So use case 10 is where we understood and used a custom metadata, which is denoted by __ MDT. We queried out our custom metadata and we found a very specific record based on whatever plant name that we provided to the method input. So this is where we were able to actually fetch a specific value from a field of a custom metadata record, right? Very similar to how you query Salesforce objects. We did that for custom metadata here. Apex use case 11 is here. So just like custom metadata, we then jumped into understanding custom settings. So __ MDT is for metadata. However, custom objects get the __ C annotation, and very much similar to how the custom object sockle query works. We did this query. We used the binding operator to find a record for which we have put the acronym here, and if we were able to find a record successfully using the dot size function, we returned that particular value. Why did we statically annotate it with the 0th index? Because it will only go inside if this particular if condition is true, and when size is equal to 1, you can always say that there would be a 0th index element, right? And if this did not return it from here, it would simply say return nothing found, because the return type is a string. All right. Next was use case 12. So 12 is right here, and this was very simple. We wanted to return the latest 5 tasks that were created today. So we simply returned the query result, and in the query result we put 2 things, where the created date is equal to today. Today denotes the current day. It's a simple thing that sockle queries allow. And then we ordered our query by the created date desc, meaning the latest records first, descending sort. And then we limited the record count to 5. So only 5 records are returned here, because that was the ask. All right. What about use case 13? In use case 13, we generated the first name and last name based on an email address that is supposed to be in a format a_b@companyname.com, right? So we understood that there's a method called substring before that is part of the string class, and we also found a method that's called isNotBlank. So if we're able to find a value, we can use the isNotBlank function to check, right? And then finally we also used 2 more functions, contains and replace. So contains check if that particular character exists in the string or not, and replace takes 2 parameters. The first parameter being the identification, the second being the replacement. So find and replace. Okay, we are able to get the full name, the first name and the last name by these 4 or 5 methods, functions, and then we return the full name. All right, 13, use case 14. Use case 14 was all about setting up and generating a Fibonacci sequence, which is nothing but 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, I think it's right, and then so on. So basically the sum of the first 2 numbers is the third number itself. That is Fibonacci sequence. This took us back basically to the days when we used to write C, C++, C# code, and this is where we used our decision making and problem solving skills to initialize variables, use the break statement to come out of a loop, add certain kind of integers to the list first of all statically, and then using this iteration, doing some calculations and reinitializing and reassigning the values, we were able to create a list and curate a list. That was basically our Fibonacci sequence. All right, so that was use case 14. Use case 15 is here. It was about whatever you write, the method should reverse it, right? And just like the word reverse, the string class has a method called reverse. So we simply put sentence.reverse, and that did our case. Use case 16. Use case 16 had us calculating the sum of all the numbers. So instead of using a calculator, we basically created a method that would take a final number, and until which it would basically just keep adding on the summation by using the plus equal to sign. The plus equal to is nothing but total sum is equal to total sum plus I, and this is the short code of writing it, right? And we started off with 1 and we reached till that number, which is why this index is from 1 and it says less than equal to the final number. If it were from 0, it would be less than final number, but in that case the last number would not be considered, which is why we have started the index from 1. All right, What is use case 17? 17 is basically finding a minimum and maximum number from a list of numbers that is passed as input. So this returned list of integer as the output, and it accepted a list of numbers as the input. And here we were able to use our problem solving skills and programming skills to understand how to assign and keep or retain a specific number if it is either less than the other number or more than the other number. Okay, one logic for max number and the other logic for min number. And we also understood that initialization also works, right? That helps at a lot of places. Let's move on to use case 18. Use case 18 was about writing queries and also understanding how to use the add all method, right? So what we did is we basically wanted to display two kinds of records together, two sObjects. So we use the object class, which is the parent class of all sObjects, the parent and the grandparent, the actual king of all objects, which is the object class. And then we queried the account, we queried all the contacts, we got the 10 records, order by, created date, desk, the latest 10 records. And then we checked if the size is not empty. We just created a list here, and we used the add all method from the list collection that basically adds all the records from another list. So it copies all the values from one list to another. We did the same for the contact, and we were able to actually create a list variable and return a method with two kinds of sObjects, right? That was amazing. So that was 18. Let's go to 19. Use case number 19 is here. Use case number 19 was all about the schema class. I took a lot of time to explain you guys how to use the schema class, and I went inside each of these methods and we were able to understand what's the return type and then what are the methods under that particular return type in that particular class, right? So this is how we reached schema.get global describe .sObject type .get describe .get key prefix. A lot of methods sequentially placed one inside the other, but this was a very important use case that helped us understand the schema class, right? And here we basically accepted a specific record ID, and based on what kind of the record ID is, we were able to say that this is the object. So if it started with 005, we could say that this is this object. If it started with 006, we could say this is this object A or object B, right? So we're able to do that all by the schema class. Use case number 20. Let's take a look at use case number 20 is here. Use case number 20 was about basically creating a wrapper, and wrapper is not basically the person who wraps. In this case, the wrapper is basically kind of a collection of different kind of entities clubbed together so that we can package and bundle it and send it to the front end, right? Because not always will you create a list of objects, but we created a custom wrapper that was pretty much of our requirement. It had three kind of data, 2 string and 1 date time. We fetched this information from our user, and here we also actually took a look at and understood the user info class. The user info class has information about the current logged in user. Things like get locale, get time zone, get user ID, get profile ID, a lot of stuff was available there, right? Similarly, even the last login date was available. So we took up all of these details, we put it in the wrapper, and our wrapper was ready to be returned as the return type of the method. That told us that not even primitive data types, but we can actually create custom data types and non-primitive data types, and they can also be used to return as part of the method return param, right? So that was 20. Let's go to 21. Use case 21 was to check lead duplicate. So we normally have duplicate rules configured in the system, which are very straightforward, and you can actually put conditions there. But if things go berserk, things are a bit complex, you can definitely choose to write duplicate rules on Apex, right? So considering similar kind of requirements, we took in a lead record, and we are able to figure out by checking if the name, the email, and probably the lead source and industry matches with any other lead in the system. So this was the check we put, and we also wanted to ensure that we are not actually matching and comparing the same lead. We put a ID not equal to check, meaning take a look at the entire database, but don't just take a look at this particular lead record that's currently in question, right? If we were able to find a record, we return true, or else we return false, right? So that's all we learned from this particular use case 21. Let's move on to 22. 22 is right here. So we wanted to check if two particular records have the same parent. We accepted two contact records as the input param, and we simply use the .account ID variable. What we did is basically we took a look at two contacts. We checked whether both have account IDs. if both have account IDs, we simply check if are both same or not. Because account IDs are unique, we could simply use the double equal to sign that is used to compare, and not equal to sign is basically not equal to, as in English, right? If we were able to find a match, we simply return true, which means the con has same parents. If it did not go inside this if condition ever, it would always come to line number 11 and return false, meaning none of the contacts have same parents. Cool. Let's move on to 23. 23 was reassigning a case based on criteria, and it was about reassigning the case to a queue. So we wanted to do a queue assignment, right? So we took a case record and we took two static final values which do not change in the entire course of the transaction of the Apex method, and we simply queried out our queue. We understood that queues don't have a separate object with name queue, but they are part of the group object, right? But if you mention type equal to queue and you put a developer name, you'll be able to retrieve or specifically mention which kind of queue do you want. We got that particular information, we found the size equal to 1, and then we were able to assign that queue ID to our case record. We only did that if the case record met our criteria, which was the priority type should be high and case origin should be web. Okay, that was use case 23. Let's go to 24. 24 was about finding the max revenue generator account, right? So what we wanted to do is we could have thought about, looked into it by using a for loop and all of this stuff, but we simply used our understanding and the power of SOQL queries, right? We took a look at all the accounts where the annual revenue was not null, meaning it had a value, and then we ordered it by the annual revenue desk, meaning the highest one first. And that's it. That gave us the scenario and that gave us the result. We put a limit 1 tag here, and if the size was equal to 1, meaning it found a record, it returned that very first element. All right. If it did not find it, it returned null. All right. That was use case 24. Moving on to use case 25, which returned a merged list. Now merged list is where I wanted to tell you guys that, you can use set as a collection to avoid duplicates, right? List can have duplicates and they are ordered, but if you are not worried about the order, the sequence, but you want to ensure that there are no duplicates in your collection, it could be because you are upserting data, it could be because you don't want to print or send a notification to the same person twice, you always want to prefer a set collection over a list collection, right? So we created a set variable, and then we actually wanted to just get information from the case object. So we created two queries and we fetched the case records into both of them. And again, just like the list variable, you have an add all method on the set variable. So set variable takes the add all method and you can actually pass an entire list. What that means is all the elements of the list are copied from the list to the set. Now what this does is this creates that set. It adds all the values, but it ensures that it does not have duplicates, meaning if the same record was found on both of the list variables, it would only keep it once, it will not keep it twice. So that was the idea of this particular use case. That was use case 25. Let's move on to 26. 26 was about assigning the case to queue, very similar to what we did previously, but I also wanted to take you through how to create a custom label and use it in Apex, right? So we did a query where the type is equal to queue and the developer name is something that we fetched from a custom label, right? So system.label.myPrimaryQueue, the label is the myPrimaryQueue. It was holding the value, or rather the developer name, or rather the API name of the queue, and we just put a limit 1 tag so that we could find the right queue to assign our case, right? And then we also took a look at the case record to modify, because we wanted the owner ID. We had only the ID field on the case rec. And then once we found the record, we just said that put the queue information on the owner ID and update that particular record. So we used a database command, right? So that was use case 26. 27 was about generating an account report. And this account report was basically for all the accounts whose opportunities are performing or have revenue, or rather the amount more than 80K, right? So what we did is we basically iterated over each of the opportunities which have a good revenue, which is basically this where clause where amount is greater than 80,000, and then for each one of them we simply created a set, right? Because there could be two opportunities under the same account with amount more than 80K. So do I want that account to be listed twice? No, I only want it once. So that was the call for creating a set variable to avoid duplicates, and I just added all the account IDs here, and that's what we returned. So this generated the account report of all the opportunities under them, all the accounts whose opportunities are performing very well. right? There was 27. What was 28? 28 is here, generate cases by origin. We wanted to look at a map collection because we worked a lot with list and set, but the real deal and the actual complex criteria that happen and that create panic among students and people who are developing or writing code is the map collection. So I tried to get it a bit easy for you. We created a collection that had a key, which was a plain key, but the value was again a collection, which was a list of case, which means a list of sObject. What we did here was we queried our case records, we iterated over them, and we basically built a beautiful logic of understanding whether the case contains its value by checking the key, and if it did not, we actually created a new list variable and we used the put method from the map, right? For those of you who looked at the use case and you're able to understand it, amazing. The battle is half won, right? So this use case was primarily about handling map collection and not being afraid of the fact that you get complicated values inside a map collection and it can get worse, but it's always easy once you have it sorted in your head, right? So that was use case 28, and then finally the use case 29 was about retrieving record types. We again jumped into understanding the schema class because the first use case was not enough. So we looked into schema.globalDescribe.get, and this time we used the get method so that we could get specific information about the object that we are currently talking about, and then we used the get describe and then get record type infos by developer name. What this did is it gave us a map wherein the value was schema.recordTypeInfo, meaning everything about that particular record type for each one of them. So we took a look at that particular record type info value by using an iterator on the map, and then if it was not a master record type, meaning not a standard record type but only custom, we created a list, and that list was basically a list of string, and we finally added and returned that particular list as our result, right? So that was 29 freaking use cases that we did in the last 29 videos, and I'm sure that you learned a great chunk of deal. If you were able to write this code alongside me or even yourself, that's amazing. Kudos to you. Just drop a comment below, let me know. Now what's next? What's next is Apex triggers. Like I said, this is a already recorded video. It's a beginner explainer, and then it takes you through 30 practical use cases that you'll be handling in your day-to-day activities being a Salesforce developer. What I've done is I've basically collated all of that videos into one single video to make it more like a crash course and to ensure that this particular video is part of my curriculum, because that's what's next as part of our curriculum. So what did we learn from the use cases is what I already told you, and the next thing is triggers in Apex. So the next video is going to be a long one, and I'm going to put a community post wherein I'll talk about something. So keep your eyes open for the community post and stay tuned for more. I'll upload the triggers in Apex video probably in a day or two, and then we can jump into the next use cases or the next set of videos that we have as part of our curriculum, right? That's all from this video. My speed was probably 2x because this is for people who have actually been through the 29 use cases, and for those of you who have actually been through it, you kind of pretty much know what we did. So it was in a speed that you would understand, but in case I went a bit too fast, feel free to reduce the video speed by 0.5x so that it's a bit more understandable. All right, cool. That's all from this particular video. I'll see you in the next one. Bye.